Okay, homework 4 is now posted. Yay. Homework 4 is a pretty mathy assignment. So those of you that look at all that scary math. Homework 4 is an implementation of the bisection method. And I promise to talk more about this in a bit. But all of this stuff up here is sort of the preamble to describe what the bisection method is. And then down here is a description of the program that I'm asking you to write. And I think it looks scarier than it actually is. Questions about what you're turning in today?
It's kind of like a aesthetic question. I've noticed it in class too. When you print out a list of numbers and you have them separated by commas, there's always a comma at the end of the last term. Mm-hmm. Is there any way to get rid of that?
Sure. What you can do is you can print out the number, and then if it's not the last term, print out the comma. So you do actually have to.
You have to fill the whole number.
Yes.
Is it worth it? Do you really care?
You know, it shows me that you care. Just by asking the question, Rebecca, you care. Yeah, it irks me too.
But isn't for this program that's due today, the program, when you do the even or odd, it won't calculate the 1? You can say, I mean, the way you showed it is saying, well, n is not equal to 1, do this.
Sure. So if your loop, the way you built your loop is not generating the 1, then right after the loop you can print out a 1, and that'll take care of your hanging comma. There's so many ways to handle it, and I'm not going to take off if you have a hanging comma, but you know, above and beyond, got rid of that hanging comma. Nope, I need more. There is actually a backspace character in the ASCII character set. I haven't tried that. So you could try printing out the backspace character after the loop is over, and it might. Let me pull up a terminal here. Right here, \B is backspace. I don't know. I suspect that won't work, but it might work. So you've got the comma there. The loop is over. The comma's sitting there, and then you do cout \B and hope for the best. I bet it won't work, just based on what I know about terminals. All right. So today we have Sabrina. You're prepared, Sabrina? Good. And Wednesday we have Jonathan Standen, and Friday we have
Tom.
How do you say it?
T-O-N-G.
Tom. Okay. And you will be doing artificial intelligence, and Jonathan will be doing net neutrality, and Sabrina's doing SOPA. Yay, SOPA. Today what I want to do is talk about for loops a little bit more, and try to do a somewhat interesting example. And I will once again convert between for loops and while loops, just to kind of emphasize that they are in fact the same. That you can always do with one what you can do with the other. I will then talk about nested for loops. So what happens when you put a for loop inside a for loop, or a while loop inside a while loop? You can get a lot done with that. At that point, I'll probably pause and do the presentation. Then I'll demo and discuss this monstrosity here, and finish, if I have time, with a beginning discussion of user-defined functions. So you've seen lots of functions already. C in and C out are functions. sine and cosine functions, what happens when you want to build your own function, which is really part and parcel of computer science. And that's what the bisection method really is getting at, is getting you to build your own functions. Okay, let's do a couple more for loop examples. So the first example I wanted to start out with was sum up the first and positive odd integers. And we want to use a for loop. So I'm going to ask you, you've seen me do this before in a previous example with a while loop where we were generating the first n odd integers. Let's just really quickly go through that again. So I'm going to ask for how many odd integers. And I'll get that information into a variable, let's call it capital N. And we talked a little bit about this last time. So I want to sum up these integers. It probably, before I get to that point, what I should do is take baby steps towards that point. So what I'm going to do is, instead of summing up the odds, I'm just going to generate the first n odd numbers and then see if I can turn that into something that I can sum. And I want to use a for loop. So let's remind ourselves how for loops work. We start out with the initialization step. So when the loop is first encountered, this statement happens, I equals 1. Then this statement is checked, is 1 less than or equal to n? And if that's true, then run the loop body. At the end of the loop body, we go back up here and we increment, and then we check the condition again and go through the loop if it's true, and we quit the loop if it's false. So it's somewhat a puzzling order. This happens first, then this guy. You run the loop, then this guy, loop, this guy, loop, this guy, loop, until this condition becomes false. So the initialization only ever happens once. Why the funny syntax? Why for loops at all? Does anybody remember what the syntactical point of a for loop is? Having all the iteration information at one location in the program. The initialization of the index, the increment of the index, and the loop condition are all in one place, as opposed to a while loop where you initialize before the while loop starts, the loop condition is in the while loop, and then somewhere in the body, we do not know where, there's an increment. This gets all of those things in one place. So, is this a loop that will run precisely n times? Yes, it starts out at 1 and it quits when I exceeds n. Odd numbers. How do I generate odd numbers? Do you remember the formula? 2i plus 1. If I do plus 1, minus 1. So let's just really quickly check and see if this is doing what we want. Let's do the first 5. 1, 3, 5, 7, 9, and in fact there are 5 values. 1, 3, 5, 7, 9, 5 values. So that's good. So here's the point of today's exercise, the little trick that you will use over and over again in this semester. How do you sum up the values, these odd values? How do we collect them in a sum? Some of you may have seen this trick before. If you know it, share it.
Use a string.
String isn't going to give me, it's not going to give me sort of 1 plus 3, which is 4. It's going to give me 1 plus 3, which is 13, right? Remember how the strings work? They just take the characters and they add them on. So that I actually want 1 plus 3 to be 4, not 13.
So can we just increment a variable by 2i minus 1?
You could do that, yeah. So set up a variable. What would be a good name for this variable? Absolutely. And you could do something like sum equals sum plus 2i minus 1. Is that what you were thinking? That's almost going to work, and it might even work at this point. There's one element that's missing. Danielle?
You want to initialize it before the for loop.
Definitely. I have to make sure I initialize it. You have to initialize it, otherwise it might already contain a value. And then when you get here, say the first time through, let's pretend that sum just already contained the value 315. Then it's going to be 315 plus 2i minus 1, and then keep going around. And you're going to have an extra 315 in your sum that you didn't want there. What do you want this sum to start out at? You want it to start out at 0. Then the first time through, you get sum equals 0 plus 1. And then you come around and you have sum equals 1 plus 3. And then you come around and you have sum equals 4 plus 5, and so on, right? Very, very standard trick for accumulating a sum. This example right here. You get yourself a summation variable, call it sum. You initialize it to 0, and then you just accumulate the values as they're generated. Rebecca?
Do you have to put parentheses around the 2i minus?
I do not.
It'll just figure it out.
Well, what's it doing? Putting this value here and then evaluating
doesn't really matter.
from left to right. Yeah. If there was some precedence problem, operator precedence problem, then yeah, you would use parentheses to fix that. Okay. Well, I've got at the end of this loop, what's sitting in the variable sum? What value? Of course, you don't know which specific value, but describe the value. What is it?
The sum of all the
Number of odds.
odds.
It's the sum of the first n odd integers. So at this point, and of course, I'd like to show that to the user. So some kind of report is necessary. The sum of the first, oops. Let's see how that looks. Number of odds to sum, 5. The sum of the first 5 positive odd integers is 25. That looks good. 1. That looks good. How about 0? Even that kind of makes sense. What happened when I did 0? In particular, I'm interested in what happened to the for loop when I did 0. Yeah.
You just did not do it.
Yeah, it didn't do it. Can you explain why it didn't do it?
Because I is 1 and n is 0, so it was never true.
Yeah, so let's think about the order in which these things happen. The I gets set the first time you encounter the loop. This initialization step occurs, I equals 1. Now it doesn't go and do the loop. it actually goes over here and checks the condition. 1 less than or equal to 0, false. Skips the loop, goes down here and spits out some results. It's an extremely handy feature of for loops, that even the first time through, the condition is checked. I guess as a side note, does anybody see a pattern?
The number squared.
Yes, it is. Really easy to prove that by induction. Okay. All right. Any questions about that? Let's see if we can do an equivalent while loop. I'm going to move this guy some odds. I'm going to move it to 4. And then I'm going to copy it to while. Whoops. Didn't mean to do that. So just to continue the notion that for loops and while loops are essentially interchangeable, how might I convert this to a while loop? So I equals 1, good. I have to change 4 to while. What happens in here? Yeah, throw away everything but the middle guy. And now what? Where should I put the I++? Here or here? It matters, right? Definitely matters. If I put it here, it's going to turn into 2 before it actually gets dumped into the sum. The whole thing's going to be shifted up by 1 odd number. So it does matter, and you have to think about it every single time about where the order, whether the order matters. I think that'll do it. Let's recompile and run this thing. And yeah, it looks good. But now what you see is that triad that was sitting in the for loop is now spread out all over the place. You have initialization up here, loop condition here, and increment down here. There's nothing a priori bad about that. It's just for loop kind of collects all that stuff in one place. And you're going to see for loops used much more often when we learn about arrays, where you have not just a single variable with a single value, but a variable with a whole bunch of values. Like one variable maybe has 100 numbers inside of it. That's called an array. Okay, let's do a nested loop example, and then I will turn the floor over to Sabrina. Okay, classic example of this is to use a nested loop to sketch a checkerboard pattern. What's a checkerboard pattern? Well, what I'd like to do is print out I think that's an 8x8. Nope, I put too many in there. Is that an 8 by 8? There's an 8 by 8. That's a checkerboard pattern. So say the X's are the black squares and the O's are the white squares or the red squares on a checkerboard. Looks really hard. Print that. I want to print out XO, 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 and then I want to do OX, 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 OX. What I want to do is I want a for loop, 2 for loops. I want one for loop that generates the rows, and then inside that for loop, I'll have another one that generates, I want one. How do I want to do this? So each row is noted by the outside for loop, and then, yeah, the inner for loop is going to do the columns. So how many rows do we have? 8, right? And let me go up here and get myself some integer variables. And how many columns do I have? Also 8. And let's not worry about the checkerboard pattern at the moment. Let's just worry about generating a square of characters. So let's do something like cout x. Now think about how this is going to work. The outer loop runs and sets I equal to 1. Is 1 less than 8? Sure. So go in here and do the inner loop. So now j is set equal to 1. Is 1 less than 8? Sure. It's going to print out a character. And then where's it going to go after that? It's going to go up here back to the I or back up here back to the j? It goes back to the j, and it does it 7 more times. So for each I, how many times does this guy run? 8 times. For each I, this guy loops through 8 times. When it's done, it comes back up and does the next increment in I. So you're going to get this loop running 8 times, and it's going to run 8 times 8 times. So let's just see what happens when we do this. How many X's are there? 64. Yes. Not quite what we want. Is there a way to get 8 of them per row? Sure, I need to print out an end line somewhere after each 8 characters. Where would be a strategic place to put that end line to make that happen? Between this guy and this guy, right? Right, when I get to here and this loop is done, I've printed out 8 X's. So it would be good at that point to insert an end line. Let's see what that looks like. Everybody still with me? Good. Okay, so we've got 8 rows of 8 characters being printed out. Here's the hard part. Does anybody know in this picture what makes a spot have an X versus an O? Is there some kind of test that you can put on the integers I and j that will tell me whether to put an X there or an O there?
For even if the X's are in the odds, and for odds, the X's are in the even.
So which
for row 1, the X is in the first place is odd.
J is odd here?
Yeah.
Okay.
And then for even, for like the second one or the fourth one.
So let's pretend this is 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. In fact, yeah, let's do that.
Add them together.
Yeah.
If you add them together and they're even, it's an X. If they're odd, it's an O.
Okay, so this is the 1, 1 spot. 1 plus 1 is 2, which is even. This is the 1, 2 spot, 1 plus 2. Okay, so it looks like it's going to work on that guy. Let's go down here. This is what spot? I equals 2, j equals odd. That might work. Okay, so there's what seems to be the clue to whether to paint an X or an O. How do I make that happen in my program? Say again? I need an if-else statement. Where am I going to put it? Yeah, around this thing here. If, okay, what's the condition? Else what? Whoops. And I probably should clean that up a little bit. Notice as I built this program, I built up from, I didn't try to do the whole thing at once. I built a loop that ran 8 times, and then I stuck another loop inside of it that ran 8 times, and then I just printed out a character to see what was going to happen. This is how you need to build up these programs that I'm assigning to you. Let's see if this works. Order of operations, exactly. How do I fix it? There you go. Good job.
Is there any way to change the vertical spacing on the terminal?
Not really. I mean, there are limitations here. You might do well to put a space here and perhaps here. Whoops. Can't have 2 characters there. Let's do this. That's a little better. But yeah, now we're in the territory of ASCII art, which I am not a master of. Sabrina, come on up and do your thing. Do you need to log in or anything like that?
Yeah.
Would you like your presentation to be immortalized on YouTube?
Sure.
Then I'm just going to leave it.
Okay.
What are you blanking, right?
Stop.
I know, isn't that annoying?
Yeah. Oh, and my S is cut out. Both my S's in my name too. Okay, so I'll give you a hint in case you haven't read the piracy word, because I have a treasure map. We all know pirates love treasure maps. And so SOPA is the Stop Online Piracy Act, which began in October of 2011, and it was introduced in the House by U.S. Representative Lamar S. Smith, and it was a response to stop copyright infringement. And it wanted to curb access to like overseas websites that allowed pirated content and counterfeit products. So this bill intended to have internet search providers not allow access to these websites. So if I typed it into Chrome, it'd be like, oh, no, like denied. And advertisers cannot support it. So if I was this advertising company, I couldn't be like, hey, like put my ads in your website. And also PayPal would not be able to transfer funds to them. And they also did not want search engines to show it. So if I typed it into Google, I would be denied again. And there are some people who liked it, like media businesses, Time Warner Motion Picture Association of America, they're like, yeah, like we're losing money when people just get our stuff for free. It costs millions of dollars to make and we're getting zero profit. And then there's a lot of people who didn't like it. Like YouTube, Google, Facebook, Wikipedia, Amazon, yeah, a whole bunch. They didn't want the web censored. And so they coordinated this, 12 to 24 hour blackout. And I have an example of how Google's was. And right here at the bottom, they have the Don't Censor the Web. They got over 4.5 million signatures from the users on that day. Whee! Back. Okay. So it was introduced in October 2011. They coordinated the attack in January, and a couple of days later, the House was like, all right, we're just going to shelf this because the response was so strong, like, no, we don't like this. And as of now, I couldn't find any current status about it. And when it was shelved, there was another act. It was the Open Act, but that one would only stop the transfer of money to those websites. And that wasn't really well received. And so right now, all we have is the 1998 Digital Millennium Copyright Act. So like with YouTube, you may notice that if there's like a song online, it'll be like, hey, like this infringes on copyrights, because they're like, this is our stuff. So they send a notice to YouTube, YouTube sends it to the user. And after this, that's kind of when Mega Upload went downhill, because the US Department of Justice seized all of that and stopped it, because all these users were just getting this stuff for free. Like, if you would only get 72 minutes if you weren't a paid user, and if you were a paid user, then you could just have unlimited. And that's how they got money off of giving stuff that wasn't theirs. And so at the end of the treasure map, well, we don't really get nothing except keeping our internet freedom. Any questions?
Are there any ongoing legislative policy initiatives to redo this?
Yeah, I tried looking like what it currently is at, and I got nothing. Even websites were like, yeah, this is outdated. And I guess right now it's kind of not an issue compared to other things that the Senate and House would rather deal with.
Did you come across anything similar in Europe?
Oh, no, actually I did not think of looking at other countries.
That's okay. Any other questions, comments? There's one back there.
So there's some websites where you like can't even type them into the address bar, but you can search them on Google and look to them that way. How does that work?
I never even heard of that.
Well, this didn't pass, so I guess you're.
Do we have an example?
Yeah. So type in ATDHEnet on Google.
ATDHE.
So now search that on Google.
ATDH.
I know Google saves like the cache from most of the websites, and so they have like a previous saved version of it. It's not live.
Oh yeah, this is under a different domain.
Oh, it went to .eu. Yeah.
Went to Europe.
But they block all of them. I don't know if that's just a strategy about the website or what.
Yeah, they've been taking down. The Department of Justice has been taking down sites that are giving access to copyrighted material. Yeah. But I don't know. I mean, essentially, does anybody talk about DNS in this? Does anybody have the question about DNS, domain name service? No? Okay. Anyway, when you type in an address up there in the bar, what happens is it gets translated to a number. And there are actually, I'll make up a number, something like 8 root DNS servers in the whole world responsible for converting the name to a number. And
the U.S. essentially, by virtue of, I guess, inventing the internet, has a fair amount of control over the conversion from names to numbers. And so what they can do is essentially, you can have the number, but we're going to take the name. The Justice Department takes the name. So what was it, ATDHE or something like that? They essentially take the name out of the root servers so that it doesn't transfer to a number, or really what it does is it transfers to a number that's controlled by the Department of Justice. Okay, let's get back to, oh, thank you, Sabrina. Very nice. Let me demo the next homework. So we've got this bisection method. You know what? Let me see if I can find an animation of the bisection method. A picture is worth 1,000 words. Okay. So a big problem in mathematics is trying to find zeros of functions. So you all learned about functions back in 8th, 9th, 10th grade, something like that, where you graph on the xy plane x equals f of x, and every coordinate is essentially the x coordinate, and then f of x is the y coordinate. A really common problem in science and engineering is to find out where a function crosses the x-axis. And for some functions, it's a really difficult question, or it's a really difficult answer to come up with. I don't know what this function, oh, here's the function right here, x cubed plus 4x squared minus 10. So if I want to find out where that thing's equal to 0, it's hard. It's not as hard as some, but it's hard. I can try to factor it and see what the factors are. I could try to plug in. I could try to guess. For example, what is that theorem? What is that method where you take factors of this coefficient and this coefficient? The rational root theorem. Remember that? The rational root theorem? I haven't thought about that in years. So you take the coefficient on the front, which is 1, and the coefficient on the back, which is 10, and you take rational combinations of divisors of those guys. So divisors of 10 are 2 and 5, or 10. And you start testing those. Like, is 10, plus or minus 10 a root? I don't know. Is plus or minus 2 a root? Is plus or minus 5 a root? When it works, that's great, but sometimes that just fails. So what I'm presenting you this week is a different method, a numerical method for approximating the zeros of a particular function. And let me see if I can reload this thing, or maybe go back. No, apparently I can't go back. Maybe I can find a... Ooh, don't want that one. Okay, so I wish I could pause this thing, but I can't. But you can kind of see the thing bouncing back and forth and narrowing in on the crossing. And that's essentially what it does. It just kind of cuts the interval in half and sort of focuses in on the crossing. Nope, that's not going to work. Oh, there aren't many, are there? Oh well. It's probably because the bisection method is a terrible way of finding roots. Okay, let me demo my program for you. So here's the bisection method for x squared minus 2. X squared minus 2. What are the zeros of x squared minus 2? Where's the function x squared minus 2 equal to 0? Okay, so we know how to solve that one just algebraically, and probably would never use any numerical method to find the zero of this. But let's do so anyway. What I'd like to do is approximate the roots of this thing to this particular tolerance. You see a long, scary looking expression there, 1.000 yada 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 times 10 to the minus 4, which is 0.0004, sorry, 0.0004. That's a small number. So presumably if I can approximate the solution or the root of this polynomial to within 10 to the minus 4, I've got a pretty good grip on it. Does anybody remember what the square root of 2 roughly is? Yeah, 1.414, very good. So let's see if my program actually does that. Now, as with most numerical methods that find roots, you have to give the program an initial guess, a place to look. This is true of Newton's method, it's true of the bisection method. You have to give it an initial guess. So the initial interval that I ask for here, xl space xr, is a number that's less than the root and a number that's bigger than the root. So what's a number that's less than the square root of 2, but close to it? 1. And what's one that's bigger? 2. So my algorithm gets these two numbers, it gets the tolerance, and it goes off and runs the bisection method and comes back with 1.414 yada yada yada. And this is the approximate solution. This is not exactly the square root of 2. It's just the square root of 2 up to the tolerance 10 to the minus 4. And when I take my approximate solution and I plug it into f, what should I get? I should get something that's close to 0, right? And in fact, I do. I get something like 9 times 10 to the minus 5. So that shows me that this approximate root that I found is pretty good at making f 0. It's not perfect at making f 0, but it certainly makes f pretty small. And if I want, I can drive that down even further by, say, 1 times 10 to the minus 10, say. And you'll notice it comes up with 1.4142135. I don't know how far out that's good, but it's better than it was. It's a closer approximation of the square root of 2, which we happen to know is the correct answer. It's a closer approximation. And notice what it does to the value of f. When I plug in this better number, what do you notice about f of the better number? It's much smaller. Right? F of the better approximation is much closer to 0. It's like 10 to the minus 10 instead of 10 to the minus 5. There's another root here, right? Let's see if we can find that one. What would be a good guess for the other root? Left side. Maybe negative 2? Oh, sorry. Thank you. Negative 2 and negative 1. And that gets me the negative square root of 2, or it gets me close to the negative square root of 2. This is how your program will run, roughly speaking. There may be a few details in the homework that I haven't implemented yet, but roughly speaking, this is how it'll go. We'll talk more about how to get some of these things done in a bit. For example, there's one really interesting thing here. Notice I can hit enter and I can get the default tolerance, or I can type in a tolerance of my own to override that. How do we actually do that? I'll talk more about that on Wednesday. But for now, let's go and talk a little bit about user-defined functions in general. So the point of this exercise is really just to get you guys comfortable with user-defined functions, functions that you write yourself. I'll leave you with a really simple example of a user-defined function. how do I write my own function? Hold on. Okay, does everybody see what's going on here? I define the function up here. The name of the function is f. What are the arguments to the function? This function takes one argument. By argument, I mean what's the thing inside the parentheses? What do I feed into it? It takes one argument of type double, and it returns a double. What does it do in the meantime? Well, if I feed it a double, it goes in here, it takes on the name x, and then whatever happens to x in here, it gets returned out to the main program again. So let's look at what happens here. I ask for value y. Ignore all of this. Right here is where I actually use the function f of y. So this is a signal to the compiler to go find f. Go find the function f. So it goes up here and it looks at this definition. And it says, take whatever number is here in y and plug it in for x in this definition up here. Now, how does this function work? Well, you go into the body and it computes x star x, which is just take the argument multiplied by itself. Once it's finished with that, it returns it back to the calling program. It returns it back to the main program. So in the end, this f of y literally turns into y star y, or whatever the result is of the calculation. And then that value is then fed out to the screen using the cout command.
So we used x's, but we didn't have to define them in any way. Can we use x's if you're writing more than one user defined, or how does that work?
Yes, so the lovely thing about what Emily's concerned about is, do I have to come up with a different variable for every function that I want to define? And the answer, fortunately, is no. I could make a second function, call it g, that, say, does x cubed, and everything would be lovely. What Emily is getting at there is something called the scope of a symbol, or the scope of an identifier. I promise to talk more about that in the coming weeks, but if you know a little bit about scope, or if you've read ahead, the scope of this symbol x is restricted to the function g. It doesn't reach out anywhere else. And notice another thing I did intentionally here. I used this variable y and I plugged it in here. You don't have to use the same variable name when you're using the function either, right? So here I have a variable y, and I called f of y, and then it goes up here, and whatever the value of y is plugged into x and then used inside the function. And furthermore, I could just as easily, I didn't do this, but I could have done, I could have used x if I'd wanted to. And that would have been perfectly fine as well. So fortunately, the way C++ is written in C as well, the scoping rules are quite conducive to reducing clashes between identifiers. If I want to use a more exotic function, for example, suppose I wanted to use, do sine x times sine x, aka sine squared of x. It's a fairly commonly used function, but it's one that's not in the default math library. Oops. I can use sin x as long as I include the math library. And in fact, the larger lesson here is that I can use any C function or C++ function inside one of my functions. I can even do couts and cins inside of a function. What you're going to be doing in the remaining negative 2 minutes here, what you're going to be doing, and I promise to talk much more about this on Wednesday, is writing two functions. Now, I've practically done the first one here. That's the function that you're actually finding the zero of. The second one, you're going to write something called bisection. And it's inside this function that the whole bisection method happens. And this is a much more interesting function because it actually has 3 arguments instead of just 1. It has the left side of the interval, the right side of the interval, and the tolerance. And it's going to take those 3 numbers into itself, do all of the stuff involved with the bisection method, and then what's going to happen at the end, do you think? It's going to return that approximation. That's where we're headed. See you Wednesday.